This is the story of an epic voyage to the most hostile planet in the solar system, Jupiter. This is an extreme world.
It's a planet on steroids.
Everything on Jupiter is big.
There are enormous lightning storms there, massive auroras.
It has the harshest and most extreme radiation belts. It has the strongest magnetic field.
It's like Earth on super steroids.
And liftoff of the Atlas V with Juno on a trek to Jupiter.
5 years ago, NASA launched the Juno probe. Its mission? To reveal the secrets of this super world and shed new light on the mystery of our solar system's formation.
What we're really after with Juno is the recipe for how you make solar systems. And Jupiter represents that very first step in how you make a solar system.
After an almost 3 billion kilometre journey, Juno has just arrived at Jupiter. It was one of the riskiest moments of the voyage, and I was on hand to witness it. There's a lot about Jupiter that's extreme. It's more than twice as massive as all the other planets put together. It has more than 60 moons, one with an active volcano, and it has no surface. Drop down into its clouds and you just keep sinking. The atmosphere steadily becoming denser and eventually turning into a kind of liquid. Juno's due at Jupiter later today and about to begin the riskiest part of its journey, going into orbit.
Will the spacecraft actually survive? This is the toughest environment in our solar system you can send a spacecraft to.
An hour before, I'll be very tense.
The reason Australia is playing a key role is because of the giant planet's position in the sky at the moment. Just as Juno is going into orbit around Jupiter, Jupiter's rising in our eastern sky. So Australia is actually the best place to communicate with it. So I'm headed off to Tidbinbilla to catch all the action. We already have some idea just how extraordinary Jupiter is. Its cloud tops are like artwork.
When you look at Jupiter, you can see all these different colors, which basically means different elements.
The different elements and chemicals create the colours, but it's Jupiter's incredible rotation that mixes them into art. It's the fastest spinning planet in the solar system. A day and night there passes in just 10 hours, and the furious whirling creates a turbulent atmosphere.
One of the extreme things about Jupiter is its extreme weather. You know, a storm on Jupiter lasts for hundreds of years. So the Great Red Spot is this storm on Jupiter that's been there for just several hundred years it's been observed for. And it's this whirling giant kind of cyclone.
It is twice as wide as the Earth, and Juno will study it in great detail and at an interesting time.
One of the most exciting aspects of Juno is we're arriving at a time when that storm seems to be changing. The Great Red Spot is shrinking now.
But most excitingly, the space probe has a kind of X-ray vision.
Juno has an instrument on there called the microwave radiometer, which for the first time will see below the cloud tops, and we'll see, do the zones and belts continue down into the middle of Jupiter, or are they just on the very surface?
And the radiometer will reveal what's beneath the Great Red Spot too. Because for centuries, we've only seen the top surface.
How deep that actually goes down, nobody has any real idea.
It could be almost like a tornado. It could be something that it's digging layers and bringing them up on the surface.
Juno's now only hours from going into orbit, and the tension's building. Hey Glenn, big day.
Yeah, it is right now.
Feeling nervous?
A little bit. I think we've got it all under control. We should go and have a look, see what's happening.
Okay. Today's so important. No one's allowed in the actual mission control area. They're all looking pretty calm in the control room.
Yeah, everything seems to be going pretty well so far with this particular part of the mission.
To follow Juno, Tidbinbilla works with NASA's Goldstone tracking station.
We have the 9 antennas throughout the world being able to track it. In Goldstone, California, they have 5 antennas which are communicating right now, and 4 here in Canberra.
At this late stage, the antennas don't transmit anything. They just listen for Juno's beeps. So nothing more can be done at the moment. It's just a matter of sitting, listening.
Yeah, there's tones coming in from the spacecraft that are telling the mission control team the events that are ticking off.
They have to track a craft that's moving incredibly rapidly. So where is Juno right now?
So it's about 240,000 kilometres from Jupiter right now and travelling just under 34 kilometres a second.
34 kilometres a second?
Yeah.
Gee, that must be one of the fastest craft out there.
Yeah, right now Juno is the very fastest spacecraft that NASA has ever had out there, the fastest human-made object.
The most nail-biting part of the journey is the arrival.
We have to fire this rocket motor and get into orbit around Jupiter, and if we don't do that just right, we fly right by.
And there are plenty of other challenges.
For us, communication, making sure that we can maintain lock on that spacecraft.
Now, the team at Tidbinbilla has done this before for many craft.
But it's in this extreme environment where the gravity of the planet, the electromagnetic fields, the discharge of energy from Jupiter could disrupt that signal. So maintaining lock is really key.
And the biggest risk? The unknown.
We're going literally where no NASA spacecraft has ever gone before.
And going with a massive craft. Juno spans 20 metres. And that's not all.
We're spinning twice a minute, so we're cartwheeling through space with this giant spacecraft with giant solar arrays, and we're going into this incredibly harsh environment that we really don't know the details of.
The fact that Juno has solar panels is remarkable. Out at Jupiter, the sun's strength is just 4% of that here on Earth.
So we needed the most efficient solar cells that we could find. Then we needed to prove that they could work in the low light and very cold temperatures of Jupiter.
The greatest difficulty, though, is protecting Juno's delicate instruments.
It's quite a challenge to get something close enough to Jupiter without being fried.
The reason is Jupiter's intense radiation belts.
Now, the radiation belts are like being X-rayed. So, every orbit it's going to be 60 million dental X-rays.
They've really had to protect the electronics on this spacecraft by putting it into a section on the spacecraft that they literally call the vault.
It's basically walls of titanium. They're over 200 kilos, all of them, and they're there to shield against the radiation.
Another protection for Juno is an orbit that minimises radiation exposure.
It's going to do these highly elliptical 14-day orbits and just come in, take a snapshot, and then get out before the radiation just fries everything.
But sadly, unlike most spacecraft, Juno's days are deliberately numbered.
In fact, it's only going to last for sort of 37 orbits, and then the whole thing's going to be destroyed. We're going to plunge it into Jupiter's atmosphere.
The cremation is to cleanse the craft, in case it's carrying any hitchhiking microbes from Earth. The reason is to protect one of Jupiter's extraordinary moons, Europa. This world is thought to have an ocean of water beneath its surface that could harbour alien life. It'd be disastrous if we contaminated it with Earth bugs. While Juno will die young, it'll have a full life first. It'll investigate Jupiter's magnificent and powerful magnetic field.
It's the largest structure in the entire solar system, a huge magnetic field, very, very strong.
Indeed, the strongest in the solar system too, 18,000 times the pole strength of Earth's. Here, our magnetic field creates the beautiful northern and southern lights, the auroras. but Jupiter's are out of this world.
The greatest light show in the entire solar system, the aurora borealis of Jupiter.
You could put the Earth into it a dozen times just in that ring of aurora material at the northern and southern regions.
But how will Juno give clues to how the whole solar system formed? To find that out, I'm heading to Monash University. Solar systems are born in large expanses of gas, like the Orion Nebula. This beautiful cloud can be seen with the naked eye but you need a telescope to see its full exquisiteness. In the sky, it's in the handle of the saucepan.
So it's a pretty spectacular cloud. It's forming maybe thousands of newborn stars.
So these dark spots are the star formation
Yeah,
regions.
so all these little tiny dots, they're the newborn stars. And see, if you zoom in, so here's a baby star, like caught in the act.
Stars and their planets form when part of the cloud collapses down to a disk. So we've got a little disk around here?
Right, so this is really important. Now, it looks dark because it's dusty. And dusty is key because, we're standing on an Earth made of rocks and dust. So this is what planets are made of. So we can see all the ingredients are here to make planets.
Telescopes have become so good, we can now actually look into these dusty disks. Isn't that stunning?
Let's take a look. I mean, no one was expecting anything like this.
Yeah.
So the newborn star's in the middle.
I mean, it looks like a solar system forming, doesn't it? The sun forms at the centre of the disk, the planets around it. So these dark channels here,
Right.
probably planets orbiting.
So these are the planets orbiting around and carving out the material out of their orbit.
So how does Juno's trip to Jupiter fit in with all this? Well, it turns out there's a problem with our creation theory, and Jupiter is at the heart of it. Theory predicts big planets like Jupiter and Saturn should form out near the edge of the disk, far from their sun, because there's plenty of building material out there. But when we started studying other solar systems a few years ago, they completely ruined the theory. They have Jupiters right next to their suns.
Finding something that it's close, it was a huge shock. What was so confusing about these hot Jupiters is that we find them so close, not a little bit close, but so close. Some of them are closer than Mercury is to our sun.
So these are pretty extreme things. In fact, we don't even know how they could survive there. The radiation from the star should just blast away the atmosphere.
So the hope is Juno's detailed studies of Jupiter will shed light on this mystery and lead to new and improved theories on how solar systems form. Juno might even find out Jupiter's not really a planet, strictly speaking, more a failed star. Like in Star Wars, we could have lived in a solar system with two suns. That is a feasible scenario.
We know our sun is quite rare in a sense that it's a single star. About 60 to 70% of stars out there are all binary stars or double stars.
During formation, Jupiter seemed to be on the way to becoming a sun, collecting way more matter than all the other planets.
But unfortunately, it just didn't collect enough, so it became a giant planet rather than a star.
So we could have kind of had a double star system.
Yes, we could have a binary star like a Tatooine. We would have lived through Star Wars scenario. That would be awesome.
Meanwhile, Juno is closing in.
We're in in the crux of things right now. The spacecraft has been firing its engine. Its closest approach, less than 5,000 kilometres from the cloud
Gee,
tops.
that's close. That's close.
Very, very close.
And the rocket burn to slot Juno into orbit is almost complete. So once that burn is finished in just the next few minutes, it's in orbit.
Essentially, yes.
Juno, welcome to Jupiter.
Mission accomplished. And in the coming months, some of Jupiter's most intimate secrets will be revealed.